Hello, it's Stat 135, Lecture 26. Last time we did test of homogeneity, which tests whether two or more multinomial distributions are equal. So the main point here is that our null box consists of a single multinomial, and we, because we're going to assume that all the multinomials are the same, and we're going to have j different draws from the box, where j is the number of multinomials that we have, and so we have our observed and expected counts as we computed before. The assumptions that go into this model is that we have a single categorical variable. It's really very similar to the goodness of fit. We have a single categorical variable. We're drawing with replacement. The outcomes are mutually exclusive. In other words, when we draw from the box, exactly one outcome is checked. For example, which allele type we have, and at most 20% of the expected cells is less than 5, again because we don't want the probability pi here to be too small, because then we would estimate our expected cells as Poisson instead of binomial. So today we're going to do a test of independence. So the test of independence tests whether two categorical variables are independent. We're going to modify the problem that we did last time, 13.8.1. We can use the same data but have a different question. The question is now, is there a relationship between whether you have diabetes and your allele type? So independence, so basically we have two categorical variables now, diabetes and allele type, and we ask ourselves, so if we take a draw from our box, we're going to have one of four possibilities checked off. We get this kind of cross classification. So you either have diabetes with dominant allele type or non-dominant allele type, or you have non-diabetes with dominant or non-dominant allele types. So you have four possibilities, of which one is checked off. So if, let's say, you have 104 draws from your box, you're going to be able to fill out a scatter diagram of diabetes versus allele type. And if it looks as shown on the left here, then there would be no correlation. And so like the best fitting line through here would be horizontal. So we would say that our two categorical variables are independent. Whereas on the other hand, if we got a scatter diagram as shown on the right here with a positive association or a correlation, then you would say that there's a dependency. So the null box now, is going to consist of basically a 2x2, and but the probabilities are determined by the multiplication of the marginal probabilities. So here I've just done a matrix multiplication of the marginals of the allele type and diabetes. So pi 1 1 is pi 1 pi 1, where the first pi 1 is the pi 1 on the left is I is 1, and the pi 1 on the right there is j is 1. So from this box we draw 104. We get our observed or contingency table, as it's called. 12, 4, 39, 49. We can compute totals on the margins, and the null hypothesis is that Pi ij is pi I times pi j, in other words, a product of the marginals for all i's and j's, and the alternative is that for some I and j, they're not equal. So we can estimate pi I and pi j. So in sort of a very natural way, like we discussed for a test of homogeneity. So pi 1 hat pi I equals 1 hat would be 16 over 104, and pi j equals 1 hat would be 51 over 104, and so on. So doing this gives you, we get the same expected table that we got before. The degrees of freedom is computed as follows. So we have omega 0, which is the dimension of the null space. Omega naught is the null space, and so the dimension of omega naught would be so what is omega naught? So, well, we have all of our marginals, so we would have I plus j marginals, but we have two constraints, namely the sum of the pi i's add up to 1 and the sum of the pi j's add up to 1. So we have I plus j minus two constraints, or pi I minus 1 plus j minus 1. Now, capital omega is the sample space, which consists of I times j free probabilities, except that we have one constraint, that their sum is 1. So we have ij minus 1 for the dimension of that. So then the degrees of freedom is the dimension of capital omega minus dimension of little omega. And you do a little fancy math and you get I minus 1, j minus 1, just like we had before. Then we calculate the chi-squared, and we get exactly the same test statistic that we got before, which in this case is 5.10. We reject the null and conclude that there is a relationship between diabetes and allele type. The assumptions here for test of independence, we have two categorical variables. We're drawing with replacement. The outcomes are mutually exclusive. In other words, when we take a draw, we get exactly one cell is checked off. So just like I was discussing before, you're one of several outcomes for one categorical variable, and you're one of several outcomes for the other categorical variable. And so in that cross classification, exactly one cell is checked off. And furthermore, at least 20% of expected cells is less than 5. Again, expected counts are binomial, not Poisson. So to compare and contrast the tests, it comes down to how many categorical variables you have. If you have 1, you have goodness of fit or test of homogeneity. If you have 2, you have test of independence. They answer different questions. Goodness of fit answers, does the categorical variable have the claimed multivariate distribution? Test of homogeneity asks you whether 2 or more subgroups of a population share the same multivariate distribution. And test of independence asks whether the two categorical variables are related. And so just understand that test of homogeneity and independence have the same TS and DF, and they differ by the design and the question that they answer. In the test of independence, observational units are collected at random from the box, and two categorical variables are observed for each unit. In a test of homogeneity, the data is collected by random sampling for each multinomial separately. So good to keep that all in mind. And now I gave you some practice where I asked you to determine which test applies to which scenario here. And so I think you should take some time and read this through carefully. I've actually written out all those solutions for you, and I've uploaded that to B Courses. So I will let you take your time and read through this, and I'll see you next time.